I also don't know where half the class is. Okay, so we're gonna look at BFFs for the rest of class. I asked you to have all the graphs and equations written down. Did you guys do those? Okay, good. I'm not necessarily coming to check, but I think that will make the rest of today like a little bit more helpful. So what you do need to know for the quiz, in addition to the last little part of the homework, which is also like number 2 and 3 on the notes. So if you can do like numbers 2 and number 3 on the notes, then you're good on that part for the quiz. And then the rest is just BFF stuff. All I need you to know for the quiz tomorrow for BFF stuff is the picture and the equation. So if I draw a picture, you need to be able to match the equation with it. If I write an equation, you should be able to draw me a picture. All 12 of them. All of them are fair game. All 12 of them are fair game. Do you have to do any of this stuff on the quiz? No.
None of that.
Not yet.
None of it.
Not this week.
You just have to identify pictures.
So you need to know all the pictures and you need to know all their equations. So I'm going to have a few that I draw a picture and I'm going to say from this picture, what's the equation? And then there's going to be a few that I give you an equation and you need to draw me a picture. And then there'll be a couple like 2 or 3 on the 1.1 notes. Cool. So what we're going to do is we're just going to keep actually going through some of these. We did a couple in my last class and I'll do, I guess, as many as we have time for. I'll do. I would probably do some of the harder ones. So like we looked at reciprocal, we looked at natural log, we looked at sine. Is there any one that you looked at and you're like, this is kind of a weird one. Maybe we should talk about this. Because I can pick some that I think are like a little funny that might be good to talk through. Yeah, we can do that one. That one's a pretty useless function. I think greatest integer and logistic are the dumbest functions, but we do learn about them here. So you do need to know those pictures and graphs. Will we ever talk about either of those 2 functions again? No, but they've decided they're important, so we'll do those. We can do greatest integer. Reminder, where do we find this if we don't know what these pictures look like? Textbook. So go to 106 on your textbook, which is on Schoology. So I have mine pulled up, so I'm not going backwards. But if you go to Schoology, under materials, there's a material called, it's a PDF, and it's called Pre-Cal Textbook. And if you go to page 106, that's where these start. So what actually, before we even get started, I want you to make sure that you have your equations and your graphs. So if you already did it, you're just doing a little check. If you didn't do it, we're going to do it now. So we already did identity and squaring. And then I've got 10 more. So you should have all of these matched up under their name on your note sheet. So make sure your cubing is right, your reciprocal is right, your square root is right, your exponential is right.
This will be on the
Just matching the picture to the equation.
It's a 1 over x for the reciprocal.
Say that one more time.
It's a 1 over x.
1 over x. All right, I'm gonna go down to the next 2 too. I've got natural logarithm and sine underneath those. I don't need many points labeled, but like I need to know whether it goes through the origin or not. I do want to make note that on the exponential function, it goes to the point 0, 1. So make sure you hit 1 on the y-axis for your exponential function. And then natural log goes to the point 1, 0. It goes through 1 on the x-axis. While we're looking at 2 sine goes through 0, 0. So I'm going to teach you more about the specifics of the sine graph. It goes through 0, 0. It doesn't go any higher than +1. It doesn't go any lower than -1. And it just kind of waves back and forth. So as long as you know those few things, that's enough for you right now. right, last four. Oh yeah, so
So for the natural log, it goes through 1, 0.
it goes to the point 1, 0. Okay. 1 on the x-axis. And that's really the only point I need to know on that graph. All right. Your graphs look all good? Can we go explore some more of them? So Ava said she want to talk about greatest integer, and then we can talk about any of the other ones you want to. Okay. So greatest integer was INTX. And essentially it's just a little stair step line. So you can see it. Close, open, close, open. I'm too lazy to go all the way up. We're just gonna do a handful. That's good enough. All right. This is a pretty useless graph. That being said, there's some funny things that when we fill in this. Again, whenever we fill all these domains, etc., these are all just looking at the graph. So understanding what all those words mean and using the graph to help us, oh, excuse me, see them. Okay, first thing, domain. What counts as my domain? What x's, oh my God, I'm so sorry. What x's am I using? All of them. We are using all of them. I know there's open circles, but that's because I've got a closed circle above it. So I am using every single x. So I'm going to go negative infinity to positive infinity. However, y's, are we using every single y?
Yeah.
Not quite. We're not using any of the space in between the y's, right? Like we have points at 1, at 2, at 3, but I have nothing in between them. So technically we're using just the integers. We're using the set of the integers. We're using all positive whole numbers. We're using all negative whole numbers. You can represent this a couple different ways. I'm going to write a z for the integers. Another thing you could say is you could just write the word integers and know that it's a set of all whole numbers that are positive and negative. Or you could also write like a little brace and write dot, 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 -3, -2, -1, 0, 1, 2, 3, and then dot, 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 and then brace again. So that means we're not doing any decimals. There's no fractions. It's only the whole numbers. Positive and negative whole numbers work here. You do not have to write all three. Those are just three different ways that you could write it. Whatever speaks to you, use that. What about continuity? Was this a continuous graph? Did I have to pick my pencil up to draw it? Oh, I did have to pick my pencil up to draw it. So that means it's not continuous. Every time you pick up your pencil, that means it's not continuous. Go. What about increasing, decreasing? As I go from left to right, am I increasing, decreasing, changing? Increasing the whole time, right? So I'm going to say INC for increasing, and I'm going to say my entire domain is always increasing. The whole time I'm going up as I go across the page. Symmetry, it looks like it could be odd symmetry, but I'm going to call it none because of the way the open and the closed circles work. So I'm just going to say there's no symmetry here. I know our two graphs that we've already done had symmetry, but no is also a good option for symmetry. They don't all have symmetry. All right, boundedness. Is there like a floor that we can never go below? Is there a ceiling we can never go above? Or could it just keep stair stepping all the way in both directions? Could just keep going, right? It's not, I mean, we just stopped drawing it, but we could keep going, so it's not bounded. Not bounded. All right, local and absolute extrema. Is there any low, maximum, minimum, lowest point, highest point? Nope, NA, none. What about asymptotes? Any asymptotes here? Also none. And then last we'll do end behavior. We'll say as x approaches negative infinity, y approaches something, and as y approaches positive, or as x approaches positive infinity, y approaches. As x gets smaller and smaller, what is my y's doing? They're getting bigger and bigger, or smaller and smaller? Smaller and smaller. Uh-oh, Maggie, we good?
Yeah.
You got paper towels above you if you need them. Oh, no, smell. Oh, it broke? Oh, I'm sorry. Negative infinity. Positive infinity. All right, kind of a weird graph, not super relevant, but we filled that in. How we doing? Is there another one you want to fill in together? Kate, you're gonna have to do all of these eventually. So the more we do together, the easier it gets. Yeah, right. The logistic one, the one below it. That's another weird one, but we can do that one together. All right, that graph is actually kind of funny. I'm gonna change the scale on here. I'm gonna make 1 be all the way up here. The logistic graph is always between 0 and 1, and it's essentially like an S-looking shape. It's really close here, and then it extends, and then it goes up over this way. It looks something like that. I will tell you, because it's approaching 0 but never crosses 0, we have a what there? We have a bound and we have an asymptote. And same thing at 1, we have a asymptote and a bound up there, because again, we'll never cross it. My other class asked, like, how do we know where the asymptote is? And there was one graph that I was like, well, I just know it because that's a property of the graph. At a certain point, you're going to get to it where you're like, just because I know it's in this kind of graph, I know there's an asymptote. If you don't know that, then what I like to think about is, does my graph ever approach a number and never cross it? So like I am getting closer, I'm like not going towards negativity, I'm not going down over here. I'm getting closer and closer to 0, but I'm never going to touch it. Same thing up here, I'm not going towards positive infinity, I'm just getting closer and closer to 1. So that is another key. If you're just getting closer to one certain number and not going on and on, up forever or down forever, that means we've got some kind of asymptote. Okay, so the logistic function, oh, I don't remember this one, 1 over e to the negative x. Yeah, it's not ugly. Cool. Yeah. Okay. It looks big and scary. It's really not that hard as long as you know the equation, and we just are now going to read the graph. So I've got domain first. What's my domain here? Yep, negative infinity to positive infinity. Most of our domains are that. Once we have all of these filled in, we'll make kind of like a little note of the things that are special, but like most of our domains are negative infinity, positive infinity. What about my range though? What's the lowest y I'm allowed to have? 0. What's the biggest y I'm allowed to have? 1. Good. Do I get to include 1 or 0? Do I actually touch 1 or 0? No. Parentheses around 1 and 0. All right. Is this continuous? Yeah. As I go across the page, am I increasing or decreasing or some of both? What's my graph doing? Increasing. It's maybe not increasing a ton, but it's increasing across the page. It never goes down. So we will say increasing, and we'll say increasing for all of my x's, for negative infinity to positive infinity. It might be increasing by a tiny, tiny amount, but it's still getting bigger. All right, symmetry here, I'll tell you right now that there is no symmetry. None. I know it kind of looks like it might be an odd symmetry, but because I don't have anything in the third quadrant, I have no ability to reflect it. So since it's above the x-axis, that's why there's no symmetry. All right, boundedness. This is bounded. Is it bounded below? Is there a floor I can't go lower there? Is it bounded above? Is there a ceiling? Yep. When that happens, we call it both. We'll just say both. Bounded, both. You would say bounded on both sides if that sounds better too. I just write boundedness is both. Both sides is bound. All right, local extrema, absolute extrema. Is there any maxes or mins?
Yeah.
Yep. Where? So, okay, so I get that we're approaching 0 and that we're approaching 1, but I would say no matter what point you go to on the graph right here, the next point is a tiny bit lower. And then the next point is a tiny bit lower. So a max or a min needs to be like a peak or a valley. So if it's like a max, it's the highest point and nothing around it is that high or higher. So we're gonna say there is none here as well. We did talk about asymptotes though. There are horizontal asymptotes at 0 and 1. We would say y equals 0, or yeah, y equals 0, y equals 1. And there are not any vertical asymptotes, so we'll say NA. All right, end behavior. This is a fun one to do, end behavior. So let me set it up as x approaches negative infinity, then y approaches blank, and as x approaches positive infinity, y approaches blank. As x is going towards negative infinity, what is y getting closer to? 0. It gets closer to a number. What about as x approaches positive infinity? What is y approaching? 1. Very good. So I think when I first showed you this, I was like, there's only a few answers here. Positive infinity, negative infinity, or an actual number. This is the case where like actual numbers are my answers. Cool. Want to do another one?
So the extremes, is that referring to like the x min and the x max, or like what is there like another name for it?
I would just call a min or a max. I wouldn't say x min or x max because that to me refers to like our window. Like when we're talking about our window, or x min is like our lowest x point, our y min is. The only min and a max that we have done so far is the one at the squaring function, the quadratic one. See how this is lower than everything else around it? Then that is an absolute min and a local min because nothing is lower than it. We might only have 1 or 2 more that have like extrema. A lot of these like BFF graphs do not have extrema. So,
Quick question.
Yeah.
So, on the reciprocal function.
Yeah.
Is it negative 1 over x or just
great question. It's just 1 over x. Yeah, it looked in the book. It looks like there's a space between it. Yeah, so it's 1 over x. Should we do that one? Yeah, it's kind of a funny one too. This is one we're going to spend time on it. I think it's chapter 2. We do like a whole section on reciprocal functions. Another thing you might call them is rational functions because a rational number can be written as a fraction and the reciprocal and rational is written as a fraction. It looks like this. I don't need any specific point on here as long as you have your asymptotes and you have some kind of C curve in the first quadrant and the third quadrant, you're all good to go. All right, domain. What's my domain going to be? We cannot include 0, right? 0 does not count as an answer. So we can go up to 0. We cannot touch 0. And then we can go all the way past 0. So my domain is negative infinity to 0, comma 0 to positive. All right, what about my rate? It's the same thing, right? Because I also don't have any points at 0 as well. Was this a continuous graph? No. Increasing, decreasing. This is an interesting one. So remember, we do increasing and decreasing from left to right. So as I'm going from left to right, what's my graph doing right here? Good. And then I know I jump, but now what is it doing? It's still decreasing, right? As I go from left to right, I'm decreasing. Then I jump because of my asymptote, but I get up here and then I start going down again. I'm still decreasing. I'm decreasing the whole time. So I'm going to take my domain and I'm going to write DEC in front to tell me I'm decreasing. And it's both of those intervals from negative infinity to 0 and from 0 to positive infinity. All right, symmetry here. This one does have symmetry. Is it even or odd? Odd. That's one of the ones that I just know. Like the odd ones I think are tough. There's only 4 that are odd. And so this is just one that I just know is odd. Boundedness. Is this bounded above or below for the entire graph? No. I know this section is bounded above. I know this section is bounded below, but for the entire graph, it's not bounded. So we're going to say no, not bounded. What about local? Oh, yes. I think I spent time just knowing which 4 were odd. The other thing is, I did say this, like if it's the same in the first and the third quadrant, then it's odd. So I know that this is reflected in the first and third, so that helps me remember that it's odd. But again, it's something that I kind of just like, I know I don't really have a way to remember it, which I know kind of is not a great teacher answer, but sometimes that's just the answer. All right, what about extreme at any local min, max, low point, high points? No, I don't see any. And A. Oh, we do have asymptotes here though. Where's my horizontal asymptote? I think I heard it. 0, good. Can you show me with your arms what's horizontal? Good, okay, what's vertical? Good. We often mess that up, so I like to just kind of pause, like think through it. I saw some of us do this and we're like, definitely not that. So just like think through with your brain. Horizontal asymptote, horizontal is at 0, that's y equals 0, and then vertical asymptote is in terms of x's, so that one is called x equals 0. You get my end behavior set up as x approaches negative infinity, what is y approaching? And as x approaches positive infinity, y approaches. All right. As x approaches negative infinity, what is y doing? 0. It's getting closer and closer to the axis. What about as x approaches positive infinity? Also 0. We have 4 more minutes. I'm happy to do another one with you. I'm happy to not. I will, spoiler, I'm going to ask this to all be done by next time I see you next week. So I don't remember if that's Monday or Tuesday. But after we leave class tomorrow, I'm going to say this whole BFF sheet should be done by the first time I see you next week. All the domains and range stuff. So we have done, we did 2, 3, 4, 5. We've almost done half of them. I'd be happy to work through another one right now if you want. Cosine, is that what you said? I'll do cosine. So cosine is cosine of x. And it always goes through 0, 1. And it never goes higher than 1, and it never goes lower than -1. So as long as you kind of wavy around there. What does it look like our domain is here? Oh, you've done it. It never goes above +1, it never goes below -1. Mhm. And so now that we're talking about that, that means it's bounded where? 1 and -1. So it's bounded both. It's bounded above and below. What's our domain? Oh, yes. Okay.
Wait, so the sign would that mean it doesn't go above 0?
Sign also is bounded by +1 and -1, but it goes through the origin. So it starts through the origin and then goes up and then back down. It's the same graph, just like shifted one way or the other. The domain of cosine is infinity to infinity. Range, range though only goes, what's the lowest point of range? -1 to +1. We do get to bracket there though. Is it continuous? I actually don't want you to do any increasing or decreasing for your sine or cosine. That's good enough stopping point. You have no homework, study for your quiz, and only do 5 minutes of questions before we take it tomorrow. You either know it or you don't.
Yeah.
See ya, have a great day.
They want to know
All the graphs and all their equations.
Is there going to be a question about cosine and sin, like the weighted ones? Like we don't know what base is, but
You need to know that cosine starts at 0, 1, and sine goes through the origin 0, 0. If you know that much, you're good.
See you later.
Have a good day. Thank you.
thank you.
Bye, thank you.